Hello, hello, hello. 5D. 5D, we're finding the definite integral. 0 to 5 of the absolute value of the function negative 3x plus 6. Cool. For absolute value functions, that indicates we need to find where the function is actually going to pass 0 to then kind of turn this positive, because you can't have negative values on an absolute value function, right? So this is pretty easy. We can solve this algebraically. We're going to take the function negative 3x plus 6 and find where it equals to 0. Just add 3x to both sides, then divide both sides by 3. Yeah, x is equal to 2. That is where it will cross the 0. So for the sake of doing this algebraically instead of just graphing it, we're gonna find out if it's negative or positive before or after 2. So by just plugging in really any number before and after 2. So before 2, we're gonna go with f of f1, and then for after 2, we're gonna go f3. Real simple, and just plug this into your function. So plug 1 into the function, that is negative 3 times 1 plus 6 equal to 3. That's positive. Now you plug 3 into here. That is negative 9 plus 6, negative 3. Cool. So as you can see, before the 2, it is positive. After 2, it's negative. Meaning everything after the 2, we have to flip it. We have to flip it over. So let's rewrite our integral expression from 0 to, and it's not from 0 to 5 anymore. We're going to split it up. 0 to 2, 2 being where it hits 0. This is positive. We want to find the absolute value, so we don't have to do anything to this side of the function. We can just keep it as it is. That is negative 3x plus 6 dx. And instead of adding, since this is a negative value, it'd be like if we were to add it, we'd be adding the negative value, because the integral of this side will turn out to be negative. So instead of adding it, we're actually going to subtract the negative in order to keep it positive. And from here, we're going from 2 to 5 of the function negative 3x plus 6 dx. And this is really easy stuff, just kind of lengthy, kind of the process. Once again, we're using FTC, as I've explained probably a few times earlier in this session of going over the test. Anyway, yeah, we're going to take the antiderivative of both sides and subtract the lower bound from the upper bound. So let's find the upper bound. Negative 3 times 2 plus 6. Whoops. That's not what I meant. We're actually finding the antiderivative, obviously, because we're using FTC. So the antiderivative, you get negative 3x squared over 2 plus 6x plus c from 0 to 2 and from 2 to 5. Yeah, look at it that way. So now it's gonna be a two-part FTC, fundamental theorem of calculus, obviously. So let's plug in our upper bound now. Over 2 plus 6 times 2 plus c minus our 0, that is negative 3. 0 squared over 2 plus 6 times 0 plus c. You can probably tell it's this is just going to be, this is all going to completely cancel out, you know, even the c. So let's get to this. So negative 6 plus 12 plus c minus 0 plus 0 plus c. That is 6 plus c minus c equals to 6 is our first part right here. Now let's do it again to this one. Negative 3x, whoops, negative 3 times 5 squared over 2 plus 6 times 5 plus c minus negative 3 times 2 squared over 2 plus 6 times 2 plus c. 5 squared, 25 times negative 3 over 2 plus 30 plus c minus, we already know that this is just 6. So we're just going to keep it at that. Simplify this now. Yeah. Simplify. Negative, oh man, I just blanked. Negative 75 divided by 2 is negative 37.5 plus 30 plus c minus 6. Is that right? 35 plus 30, cool. Minus c, can't forget that. Yeah. We get rid of our c's. Negative 30. That's going to add to 7.5 minus 6 equals to negative 13.5. Now let's add this all together. We have our two integrals, the first one being equal to 6 minus what we get, negative 13.5. Add that up, we get 19.5 as our definite integral, or area under the curve, if you will, of the absolute value of this function.